Alright, so next we're going to evaluate trig functions, and you do that by finding the reference angle, which is the angle formed by the terminal side of theta and the x-axis, and then you determine the sign of the function by noting which quadrant it's in, and then the value of the function will be the same as the value for the reference angle. So here we have an example. You can pause the video and try it out. And here we're trying to find what cosine of 150 is. And you know that the reference angle is 30 since there are 30 degrees between the terminal side of theta right here and the x-axis. And since the angle is in the second quadrant and we are evaluating a cosine function, the value will be negative. So cosine of 150 is equal to the negative of cosine of 30, which is negative root 3 over 2. Here we have a second example of a trig function, and you're trying to evaluate what sine of theta is, and theta is equal to 23 pi over 6. You can pause the video and try to figure it out on your own. So here's the solution. The reference angle here is going to be negative pi over 6. You can also calculate that by subtracting 4 pi from the original angle. And then since sine is in quadrant 4 here, sine's negative in quadrant 4. By all students take calculus, so you know it's going to be negative. So here, sine of theta is negative 1/2, which is the negative of sine of pi over 6. Here we have the reciprocal identities, and basically cosecant is the reciprocal of sine, which is the reciprocal of 1 over y over r, which is sine. So cosecant is the same thing as r over y. Secant is the reciprocal of cosine, so it's equal to 1 over cosine, which is the same thing as 1 over x over r. So secant, is equal to r over x. Cotangent is the same as 1 over tan, since it's the reciprocal of tan. And you know that tangent is equal to sine over cosine, which is the same thing as y over x. So cotangent is equal to cosine over sine, or x over y. Here we have the Pythagorean identities. The first one and most important one is sine squared theta plus cosine squared theta is equal to 1. Basically, we derive this by constructing a right triangle within the unit circle. And you know that this leg here is going to be sine, this leg is going to be cosine, and the hypotenuse is going to be equal to 1. So if we plug that into the Pythagorean theorem, we get that cosine squared plus sine squared is equal to 1. Here are the other two Pythagorean identities. You derive these by dividing each term of the first identity by either cosine squared theta or sine squared theta. So you get tan squared theta plus 1 is equal to secant squared theta by dividing each term by cosine squared theta. And you get 1 plus cotangent squared theta is equal to cosecant squared theta by dividing each term by sine squared theta. Here's an example of a problem that you can solve using a Pythagorean identity. You're given that the angle theta is located in quadrant 1 and that cosine of theta is equal to 10 over 17, and you're trying to find the value of sine theta. So basically you plug your given values into the trigonometric identity sine squared theta plus cosine squared theta is equal to 1. So you know that sine squared theta is equal to 10 over 17 squared is equal to 1. You solve that out, and essentially you get sine of theta is equal to the square root of 189 over 17. And if cosine is equal to 10 over 17, that value could be either in the first quadrant or the fourth quadrant. But since it's in the first quadrant, by all students take calculus, you know that the value must be positive, so it's going to be a positive value. So next, we have the area of a triangle, and basically, here's the proof for that. You know that from your previous geometry experience, you know that the area of a triangle is equal to 1/2 of base times height. And here we're constructing a right triangle within an acute triangle, and the opposite leg of the right triangle is equal to the height of the acute triangle. And here we're using letter A to represent the length of the base and letter B to represent the length of the hypotenuse. And in any given triangle, there are going to be lowercase letters representing the sides and uppercase letters representing the angles. And corresponding letters are going to be across from each other. So side C is going to be across from angle C, etc. And anyways, here we know that sine of C, this angle here, is equal to the opposite over the hypotenuse. So the opposite here is height. And so we multiply both sides by the hypotenuse to get opposite is equal to hypotenuse times sine C. So basically we know that the opposite side of the right triangle is equal to the height of the acute triangle, and that the hypotenuse of the right triangle is equal to side B of the acute triangle. We sub those in to this equation and we get that height is equal to B sine C. We sub that into the original area of a triangle formula we have here, and we know that the base is equal to A, or we're representing the base with the letter A. So we get the area is equal to 1/2 sine of AB times sine C. There are 3 area formulas that you can use depending on which sides and which angle are given to you. When you're calculating the area, it has to be 2 adjacent sides with an included angle. So you can have 1/2 AB sine C, 1/2 AC sine B, or 1/2 BC sine A. And depending on which values are given in the problem, you can use any of the 3 of these. So here in this example, you're given the values for side C, side A, and angle B. So you want to use 1/2 times A times C times sine B, since those are the values that are given to you. And you're trying to find the area of this triangle to the nearest hundredth. So you're going to sub these values right into this equation. So you'll get 1/2 times 13 times 8 times sine 85. And if you calculate that with your calculator, it comes out to 51.80. So finally, we're going to have an area application problem. And this problem states that a rectangular beam is to be cut from a cylindrical log of diameter 20 centimeters. And these figures show different ways that this can be done, but the areas here are going to be equivalent no matter which way you cut it. And the problem is asking you to express the cross-sectional area of the beam as a function of the angle theta in the figures, so this angle right here. You can pause the video and try to solve it out on your own, but here we have the solution. So here you know that the width here is going to be 20 cosine theta, which you know from your experience with circles and triangles, circles and triangles. The area of the triangle, then, if you're calculating one area of the triangle here, it's going to be 1/2 times 20, since we're plugging that into the triangle area equation we had before, and you want this side and this side, so you're going to have 20 times the width times sine theta, since that's the included angle right there. So that's 20 times 20 cosine theta times sine theta, and that comes out to 200, since we're multiplying by 1/2, cosine theta, sine theta. And if you want the cross-section of the entire rectangle here, you're going to multiply that by 2, since there are 2 triangles within the rectangle. So the entire cross-section is going to be 2 times 200 times cosine theta times sine theta, which in the end comes all the way out to 400 times cosine theta times sine theta. Thanks!